Hello everybody, welcome to the course VLSI Design Flow RTL to GDS. I am Sneh Saurabh, Associate Professor, IIIT, Delhi. I am the instructor for this course. During last few decades, we are witnessing a kind of digital revolution. Now, devices such as mobiles and laptops have become an integral part of our lives. At the heart of all these electronic equipment, there are computer chips which are doing all the processing or computation. And how can these chips do such computation? These chips can do the computation with the help of transistors, and inside these chips there are millions of transistors and sometimes billions of transistors working together. And these transistors are packed into a small area of silicon or small material of silicon, maybe a few square centimeters. And how can we pack these transistors in such a small area? We can pack these transistors because these transistors are of nanoscale sizes, which is even smaller than the size of the coronavirus. So these things perhaps you might already be knowing. But do you know that how a chip is designed? By designing, I mean that how do we decide that what should be the parameters of the transistors that are in the chip? For example, their length and width. Then how do we connect these million transistors such that we get the desired functionality? Also, we need to arrange these transistors and put it on the layout or on silicon wafer such that it deliver the functionality. Now, these are very mind-boggling tasks, especially because the number of transistors involved is humongous. However, we are able to do such a Herculean task or a challenging task of designing a chip with the help of a technology which is known as VLSI design technology. VLSI stands for Very Large Scale Integration, which means that basically we can integrate or put lot of transistor in a chip. So at the top level, this course is all about VLSI design technology. We understood that the designing of a chip is a really challenging task, and to simplify it, what we do is that we break the whole task into smaller, simpler tasks and organize those tasks in a form of a flow, which is shown in this figure. So we start with an idea about what we want to build, maybe a processor or maybe a chip related to security or a chip related to communication or whatever the functionality is. So we start with an idea, and then what we do is a kind of system level design. And at the end of system level design, we get a description of a design in terms of logic. And this design is known as an RTL design. And then we subject this RTL design to the implementation flow in which we decide the logical view of the design and also take it through the physical design step, and at the end of it what we get is a layout in the GDS format. So this layout basically contains all the design information, meaning what are the sizes of the transistors, how they are connected and how they are organized on the layout. And with the help of this GDS, we can do the fabrication, or we can send this GDS file to the fabrication unit, and they can fabricate the chip and we get the final chip out of it. So this is basically a VLSI design flow, and this is a very difficult task, and to simplify it we need to take help of lot of electronic design automation tools or EDA tools we call, or we also call them as CAD tools, computer aided design tools. So these tools are not push button tools, meaning that it is not that we give an input to this tool and this just produces a correct output. We need to use these tools very carefully, and we need to use or utilize our creativity while giving inputs to these tools. And once these tools produce an output, we need to use all our analytical skills to understand its output and perhaps modify our inputs. So the linear flow of design or design flow that I have shown here is actually complicated by lots of loops in this flow, meaning that we modify the inputs and then run the tools again and get the result and carry such iterations multiple times. So in this course, we'll be looking at all these complications of the design flow. And in this flow, we'll be particularly be focusing on the part from RTL to GDS, meaning that how do we transform and design at the logic level, which is an RTL, to GDS, which is the layout. We'll be concentrating on this part because this is an area where lots of design effort is needed. And that's why the name of this course is VLSI Design Flow RTL to GDS. So at the end of the course, a participant is expected to clearly understand each design and verification step in the VLSI design flow and its purpose and significance, and is able to evaluate various trade-offs. By trade-off, we mean that when we make some improvement in some parameters of a design, some other parameter may be affected also, they may become worse or so on. So designing is always a kind of balancing act. So in this course, we will be looking at those balancing act and how to come up to engineering decisions in a more systematic way. And at the end of this course, a participant will also be able to design and verify VLSI circuits using computer aided design tools or EDA tools, and in this course we'll be using open source EDA tools. So in this course, we'll be following the book Introduction to VLSI Design Flow, which has been written by me and which has been published by Cambridge University Press. To the best of my knowledge, this is one of the first books that covers the entire VLSI design flow, not only the implementation, but verification and test part also. So to summarize, this course will cover not only the basic principles of VLSI design flow, but will also give you an opportunity to gain hands-on experience with the open source CAD tools. Currently, there is a severe shortage of engineers in the semiconductor industry who possess such kind of skills. Therefore, I believe that if you do this course, it will improve your employability significantly, and you can become an asset to the semiconductor industry and can also contribute towards the nation's ambition of being self-reliant in semiconductors. So I welcome you all to join me in this journey called VLSI Design Flow RTL to GDS. See you all in the lectures. Thank you very much.